Okay, today's lesson is Unit 4, Algebra 2, lesson number 10, and the topic is interpreting and writing logarithmic equations. So let's begin with the very first task, and the task is here, and the task is right here. So you're given one example already how you're supposed to read the logarithm, right? So you can see this piece here, log base 10. So how do you read log these three numbers? What's this? It's log base 10. This is the log. I'm not used to saying the log. I just say log. Okay. So it is the log base 10. So the 10 which is next to G at the bottom, that's the base. Okay. So the log base 10 of 1000 is 3. So how do you interpret this is the exponent to which we raise a base 10 to get 1000 is 3. So that's all. So we'll write also in the form, actual symbolic form. Now you're supposed to write uh, over here, there are 4 examples. So let's write those 4 examples. The first one. Okay, so now in this example, how do we interpret this? And I'm going to write this. So basically, the answer here is 8. The log 100, so log base 10. So let's use this as the red color 10. Let me use this as 10, which is very important. So it is log base 10. So basically, this means the exponent. So let's write the exponent. So this is the exponent to which the exponent to which we raise base 10. Okay, the exponent to which we raise a base 10 a base 10 to get 100 million. So to get 100 million, so million is always 6 zeros, but we have another 2 zeros there, so 100 million and the answer is 8. Okay, so this is how we can write how do we interpret whatever the logarithmic form shown there. And how do we write this piece? I want you to write this also. Put an arrow up here to write down. It means when 10 is raised to the exponent, I like to use this red color 10. So this is the red base 10. And when you raise this to 8, the blue 8, it gives you the answer is 100 million. I hope it helps. Okay. So that's the first one. Likewise, you're supposed to write the next one. So let's fill it up. Let's really get. So the next one is log 1. So let's write it right here. So this piece is log of, they give you in the log base 10. So base 10 of 1 is 0. So what does this mean is the exponent. So same thing, let's write down the words, is the exponent. So how do we interpret this? Is the exponent to which we raise a base. So you already know what I'm doing, right? So it's easy. So raise a base 10 to get 0. So in other words, it means when 10 is raised to the power 0, the answer is 1. So both are same. This piece, writing this and writing this means one and the same. One is the logarithmic form. So this is the logarithmic form. And the one that we wrote here is exponential form. Okay. So the base in the exponential form, I use the red color as the base. This base 10, when you write in the log, you write it next to g, but at the bottom like this. So that b. And this one, the answer that you get here, so raised to, so this I'll use as 0, this one, the blue color. Then let's finish this off. So in the next case also, I'll write only the red color to stand for the base use is 10 here. So this is 2, and the number by itself is 4. So when you write in the logarithmic form, so when you write log, the base is put at the bottom, so that's the 2, and of so this will go in the log, we put the black color, that is this should be black 4, and this 16 is the blue one. No, I think I'm using the blue for the exponent, so I'll use it. So this is the 4. So this one I write, when I want to write this into the exponential form, we'll have to write the 2 first. 2 raised to the blue color 4 equals 16. There you go. So that's all it means. It means 2 is multiply itself 4 times to get 60. We know. So that piece is very easy to understand. What is the meaning of 2 raised to the power 4 is 16? And you can see I made a nice on this side also detail all different exponents for 2. 2 raised to 0 is 1. 2 raised to 1 is 2. 2 raised to 2 is 4. 2 raised to 3 is 68. 2 raised to 4 is 16. 2 raised to 5 is 32. And you can see the trend there. 64, and this is 128. 2 raised to 8 is 256. Sorry, yeah, 256. 2 raised to 9 is 512. And 2 raised to 10 is 1024. So these are all the value for different exponent for base 2 is used. And the last one is this piece. So how do we write this? Log base 5 of 2 is 25. Oh, sorry, they already gave us in the log form, so I have to just write in the exponential form. So this is same as base 5 raised to this 2 equals 25. And this is correct. So that's all it is. So 5 raised to 2 is 25, both one in the exponential form and the other one is the logarithmic form. And the logarithmic form basically means, how do you interpret? Last one time I'll say this, the exponent to which we raise base 5. So the exponent to which we raise the base 5 to get 25 is 2. That's all it means. It means 5 is multiply itself 2 times to get to 25. So in other words, what is logarithm basically means? It means how many times do you multiply 5 to itself to give or to arrive or to get 25. And you can see 5 multiply itself 5 times is 25. So you're doing it twice. So that's why the answer is 2 times. That's it. That's the understanding of logarithm. Okay, let's go to the next page. So, so there it is. So if you turn the page, there's a nice table. This table gives you 4 table subtables. I mean, there are 4 tables here. Okay, and in all these examples, you will see there's a x, there's a y. Look at this. So in each of this, you will see there's a x, and there's an input and there is output. So there is a log. Every second column, you'll see there's a log here, log, and the base used is the 2. So this is the 2. So input. So the first column, you'll see the numbers go from 1, 2, 3, and they go all the way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to 20, then 21 to 30, 31 to 40. So these are the 4 columns. All we are supposed to do is, what the heck is each of this? Let's see, just wanted to make sense. What does this basically means? We want to know. This means, it means when you write the log, so it is the log, and then we go and solve the problem, okay? Log base is used is 2, so I put a 2, the red color 2, and the number is, the input is 36, the black color, so that part I'll put 36, okay? And the answer is is the 5 point, what is that mean? It gives you 5.1699. What that means is, to interpret this, the exponent 5, this is the exponent 5, when raised to the base 2, that means that when raised to the base 2, that is 5.1699, and the answer is to get the black 36. So this basically is each of those input output in that big whole table is. Most of the numbers are decimals, it is, except few. Look at this. This numbers, then there's one here, there's one here. These numbers are whole numbers. The output is the whole numbers. But the rest, all of them, the output is the decimal. Let's see why it is. So we'll take problem that is given to us. If you see at the bottom there, let's go one by one and see, hey, what is log? I'll start with B. Let me wipe this off. So now that we understood what is this, so from the table you're supposed to write. So if you see the 10.2, in 10.2, the first question, so the first question, there are four sub questions there. So let's start. The first one says log logarithm, and I'm using the color. Look at the color that I choose. This is the base 2 of so this number is the first one is 2 there. Okay, 2, and equals the blue color. I'm writing these colors because so that you really understand. This is 1. Okay, so first of all, we need to know how do we figure out from the table. One thing, by now you should be already using your common sense and say, hey, how many times do you multiply this 2? So how many 2's do you multiply like this? How many 2's do I multiply to get to the final value 2? Because this 2. And you can see there is only 1 2. And this we know because of our exponential understanding. So log basically is undo what you do in the exponential. But here you're supposed to use the table. From the table, I want you to make a round circle like this. So you can see this, the 2 that you see here inside. So you see that 2 there. So it's already showing you log base 2 of 2 is 1. So the answer is, so question is, how do we write this? What does that means is when base is raised to, so you have to interpret that when the base b is raised to the exponent 1, the answer is 2. So from the table, you already, of course, they didn't give you the answer 1 here, but you get it from the table, right? But at the same time, you're supposed to write why it is. So the exponent 1, when base 2 is raised to 1, gives you 2. That's all it is, and you're done. So you're explaining that this bottom base is important. The next one, B, is log 32 log base 2. So from the table, so let's see, where is this 32? You go all the way. 32 is right here. So there you go, 32. 32 takes to 5. So that means the answer is 5. Because the table tells us, but what does it mean for to understand, interpret it? It means when the base 2 is raised to the exponent 5, the answer is 32. That's it. See how beautiful this is. When the base is raised to the exponent 5, the answer is 32, and you're done. So you can write in your own English words also. But so it is 5 is an exponent when raised to the base 2, uh, gives 32 only when the exponent is 5. And the next one, so log of base 2, answer is from 15. Now if you see the 15 there, let's see, where is 15 here? You can see 15 is right here. So 15 takes to 3.9096. So this answer is uh, 3.9069. Now this is in the logarithmic form. You're supposed to write in the exponential form. So I'll start with the base, the red base. So there 2 is the base. The exponent is the 3.9069 and equals, answer is 15. So this answer that you see here is also a little understanding of, I'm going a little further, why it is 3.9. Now 3.9, what's this? 3.9069 is a number between two whole numbers, 3 and 4. So why this 3 and 4 is important is because 2 raised to 3, if I raise them, so this is in addition, I'd like to show what's happening here is, so all of them are raised to base 2. So you can see 2 times 2 times 2 is 8. So this thing, 6, 9. Okay, sorry, what I'm trying to say is, uh, so, okay, this is 8, this is 16, and the number, this number 2 raised to 3.9069. See, so this number is between this and this is because this number that we have already is 15. This number is already given to us as 15. And that we have seen 2 raised to 3.9069 is 15. So, and 15 is between 8 and 16. So the answer has to be between, with this number has to be between 3 and 4, because 15 is between 8 and 16. So that's the understanding piece of that. Let's see the C part, D part, last one. So log of log of base 2 of 15 is, no, from the table you look up for 15 and you can see, oh, that 3.9 that we did already, right? 15, I think 40. I should take 40 here. So this is 40. So from the table, 40 is right here, 5.3219. So this is 5.3219. So at the same time, we need to write this into exponential form. So how do we write this in the exponential form is, the base is the 2. So this is the base. So 2 raised to 5.3219. So it is 5.23219. And the answer is 40, the black 40. You're done. It means when 5.23219 is raised to 2, you get 40. Another way to write this 40, look at this. So we do know 2 raised to 5 is 32, okay, and 2 raised to 6 is 64. So the number 40 is between 32 and 64, which can be written as 2 raised to 5 is less than 2 raised to something here, and this is 2 raised to 6, and you can clearly see the uh, because the 40 is between 32 and 64, so whatever you put here has to be between 5 and 6. So this number that you see, 5 point number, it is between 5 and 6. So this piece, which is 5.3219, is between 5 and 6. Okay, so that helps to figure out that. Let's do the last part. The next question they're asking is to solve for y. Let's write down solve for y. So question number 2, sub question A. First one is 2. I'll use the base, the red base. So red base is 2 raised to y, the blue color, equals the black. The first step is, I want you to write down, look at this. So the question is 2 raised to y is 5, right? So 2 raised to y is 5. So how do we solve this? First, let's switch to log form. And how do we switch to log form? Okay. So base, so write down logarithm base 2 of 5, the black 5, equals the blue. See this? So both are one and the same. Writing the exponential form and change it to logarithmic form, because now we can know from the table where is this 5, and you can see 5 is right here, and they already gave us the answer, and the answer is 2.3219. Okay. And another way is this answer is between, you can see this, so this, so log base 2 of 5 is a number between two whole numbers, 2 and 3. Because 5 is between 4 and 8, and 4 is 2 raised to 2, 8 is 2 raised to 3. So this number has to be 2 raised to something, that is, that whatever the question mark, it has to be between this question mark that I do, it has to be between 2 and 3. See? So it's nice understanding between which two whole numbers is the answer, and the answer is between 2 and 3, because this 4 and 8 are important. So we get it because of 2 square and 2 cube. So whatever the answer has to be between 2 and 3. Okay, so let's do So 2 raised to y is 70. Step 1, change this to the log form. So there's a base is 2. So when you write the log, I always write the base is written first, which is the 2. Let's put that 2 at the bottom too. Then you're asking the output was 70, so it becomes the input here. So 70, and the y, the blue is this piece which you write. Okay, that's the y. That goes by itself. This is how you solve for y. Again, I repeat, log form, exponential form. And from the table 70, and you will see the 70 doesn't even show up. We don't, do we have 70 there? 40 is the last. If you see over here, there's a 40 and there's no 70 there. So then how do we figure out what is this value? Can we at least write it between two? What whole numbers can we think of? Watch this, so beautiful. Now to figure this out, the table does not show. I'll just write table does not show. So if table does not show, then what do we do then? That means we need to approximate it between two numbers. Now 70, remember, uh, 70 is between 64 and 120. You may wonder why did I pick the 64 and 128. 64 is 2 raised to 6, okay, and 128 is 2 raised to 7. So that means this 70 that you see, it has to be between 2 raised to, I'm putting a box to show here, hey, what goes here? So there has to be something, and I don't know whether it is 6.1 or 6.2 or 6.3 or 6.4. We don't know this. So it has to be between 6 and 7. That's what I'm trying to say. So what we will do is we'll say, okay, this answer, the log, so this answer is going to be some exponent y. The y that you see is this y, which we are going to approximate between, it is the value. So y will take the value, y will take, y will have the value between, between 6 and 7. That's all you're supposed to write, and you're done. So we don't have the table to help us to give you exact answer, but we can always say that, okay, 70 is between 64 and 128, and 64 is 2 raised to 6, 120 is 2 raised to 7. So it has to be between these two, 6 and 7. I hope I made sense. Okay. The next question is asking is, hey, what's the log of 999 to the base 2? Now this is what we don't know. Let's see, we don't know what is it. Wait a minute. Okay, so the last question is C. 2 raised to the power y is 999. Now when you write this in the log form, see the base 2 is the base. So I'll write base 2 and the log. It means log of 999 is y. So we need to know what is this y, right? So I'll put that y. Now 999 is a big number, and you can see this 999 is between 512 and 1024, because this is 2 raised to 10 and this is 2 raised to 9. So that means in between it has to be 2 raised to something, and that something has to be this exponent question mark. I put a question mark. So that question mark has to be between the two exponent whole numbers, and the whole numbers are this one and this one, 9 and 10. So 9 and 10. So the value this is approximated between. So if they ask us what is this y, so this y is a value between two whole numbers. So y is a value between two whole numbers, whole numbers, number 9 and 10, and you're done. So 10.3 is about this equation expresses the same relationship between 2, 16, and 4. Look at one example is already given how you're supposed to do. There it is. See, log base 2 of 16 is 4, and the base is 2. So we can, on the right side, you will see that 2 raised to 4 is 16. Now, likewise, question is, can we apply it right here? Each one of these. So we'll do the first 4. I'll make it a little bigger so that you can clearly see. And the trick is, to those who are still having confusion, let me write the, okay, watch this. So now the first one is you're supposed to each of the fill this, complete this table. So there is the exponential form, this is the log form. And look at the color coding. The first one is the black. You can see the base is the 2, the red color. This is 2, okay? And the blue is the 1, okay? So the answer become, when you write in the log, write the base first. So the base is the red color 2, so that goes down, okay? And then the question is of the black 2, and the answer is the blue color 1. The blue color 1. That's it. So that's all you're supposed to write. Okay. The next one is there's a red 10. Look at this 10 there. So when you use the base, so let's put the logarithm base 10 of the number is the black one, and the answer is the blue 0. And so it means always true. Whenever there's a 1, no, log 1 is always 0 forever and ever. Okay. Now the next number is, in this case, the next one we have to write in the form of exponential. So look out for the base. The base is the 3. So I'll write the 3 first. And the blue is the 4. Look at this 4. That goes up. It means 3 raised to the power 4 is the answer is the black 81. And you already know that 3 times 3 times 3 times 3. So when 3 is multiplied itself 4 times, you get 81. That's it. So simple. This side, the next one is log 1 of 5. So use the base as this is the 5. So it is 5 raised to the 0. This is the 0 here. So that goes up here, equals the black 1. See? So 5 raised to 0 is 1. Anything raised to 0, we already know the answer is 1, right? Yeah. So that's how we do this. And there was one more last I'll do right here, because there was 10 raised to minus 1 equals 1 over 10. And if you see on the right side, you put the log, put the base as 10 at the bottom, and of the fraction. So instead of number, it is a fraction 110, and the answer is minus. So there is a minus 1 here. So this becomes minus 1 here. So likewise, you can check your answer that you did. The next one is 9 raised to 2/3 is 3. So the red color 9 is the base. So I have to put the log of 9 of 3 is 2/3. So in the question number G, they gave us in the log form. So in the log form, the base is 2 here. So there's a 2 here. So I'm going to use 2 raised to the blue is this minus 3. That will go, this is the exponent. This is the exponent. So that will go up to 2. And the answer here is 1/8. So this is like 1 over 8. And the good thing is, you remember that 2 raised to 3, if it is just plus 3, the answer is 8. So if it is 2 raised to minus 3, all you do is make a fraction and 8 is down. The next one is given 2 raised to y is 15. So this is, they give us 2 raised to y, the blue y, equals 15 here, see. Okay, so when we write in the logarithmic form, the 15 goes in the parenthesis, and the base is the 2, and the answer is the blue y. So that's it. So you get log 15, and 15 is, of course, this answer, this 15, if you see this, if you want to really understand this piece, this 15, this 15, 15 is a number between 8 and 16, but 8 is 2 raised to 3, and this is 2 raised to 4. So this has to be between 2 raised to exponent, which is between 3 and 4, because there's a 4 here, there's a 3 here, so between two whole numbers. Then this was g h, then the i's, they give us log of base 5 of 40 equals y. So we can write this as the base is the 5. So base is the 5. So in the exponential form, it is 5 raised to the blue y equals 40. See? So if you really want to know what is the value here, y, 40 is between 36 and 49, sorry, 64. So this is between 32. So that 2 raised to 5 is 32. So this is what? And this is 2 raised to 6. So that means whatever that exponent of y, this y, it has to be between 5 and 6. G. So the last question is b raised to y is x. So this can be written in the exponential form. The red one is b, so I'll write the log. So logarithm base is the red b. That's the red b. This is the b of x and equals the blue y. That's it. So this hope this helps to write two equivalent form. One is the exponential form and the other one is the logarithmic form. So both, so log is the inverse function of, so this log is the inverse of exponential. So let's go to the next question. Okay, this question is write two equations, one in the exponential form and one in the logarithmic form to represent each question. Use this for unknown value. Let's see what does this mean. To what exponent? So this is like question mark. Do we raise the number 4 to, no, do we raise the number 4? So this becomes the base. So here, base is, sorry. So this is the base, which is the base. And the blue is the question mark, we don't know, and this is to get 64. But we use, so the begin with the 4, 4 is the base, raised to uh, what exponent, so that's the question mark. So this is the question mark, it gives you 64. Another way to write this same piece is writing logarithm base 4 of 64. So this black color, I think I should have used this as 64 as the black color. That goes right here. And this is the blue question mark. And you're done. So these are two different equivalent form. Next one is what is the log? What is the log? Base 2. So you write log log. Base is the red. Always I use the red as the base. of 128 to 128. And the question is what? That's the question mark. So that becomes the question mark here. So this is one way, or you can write it as in the exponential form. That's written as is base is the 2, so that's the 2 base, and raised to the exponent 2, sorry, question mark, what raised to what number is the 128. So in other words, how many times we multiply 2 to itself? So you can see, so this will be 7 times 3, and 7 times you get 128. So this is 7 times. In other words, this answer has to be 7, because 2, what does log, what's the function of log? So what is the role log plays is that base is how many times you multiply this base to get to 128. So that's all the concept of log. So